All right, we ready for exponents? Your computer is still open. All right. So, backing up to some simple stuff here. When you are adding and subtracting monomials, meaning just single terms, and you know combined like terms, like you've been hearing that for years, right? Make sure you do not change common variables and exponents. So I pointed out number one here. We've got 9x squared y minus 10x squared y. Now, we went through this, everybody was like, yeah, I totally know what to do with that. And then when I gave out the assignment, I had one person earlier today that automatically did 9 times 10 and got a negative 90 and canceled out all the variables. Does that make any sense at all? No. Not to mention the fact he was like multiplying and dividing at the same time. He didn't realize what the heck he was doing, but this is why we're talking about this stuff. I want you to think about the fact that you have been doing algebra literally since you were in kindergarten. What's up?
My test wasn't as missing, so I figured I didn't write my name on it or something. I'm not going to be in your class today, so
okay. But I'm teaching right now, so you can't come interrupt my class for stuff like that. So that might be it. I do have some without names on it, but we can't deal with it right now.
Okay.
Because I'm teaching. Okay. All right. Oh, thank you. I was about to swing the door back open. Seriously? Sorry, did I slam it in your face? Because I didn't mean to. Okay. All right. Okay. So anyway, you've been doing algebra since you were in kindergarten. If you have 3 teddy bears and I give you 1 more teddy bear, now you have 4 teddy bears, right? That's like 3x plus x gives me 4x. It's the exact same thing. So when you get weird stuff, or what you might think is weird stuff, you have 9 of these things minus 10 of these things, and that gives you how many of those things left? 9 minus 10 is negative 1, so I get a negative x squared y. I think if it's just a plain old x, you're less likely to do those mistakes like you maybe have early on, but I don't think I'll do that anymore. But for some reason, when we get more variables, then some of y'all start to do strange things. The subtracting 6w from 8w, is that going to give me 2w or negative 2w? 2w, because I'm subtracting this from this. So that is 8w minus 6w. That gives me 2w, right? So wording there, just be careful with that kind of stuff. Okay, bless you. All right, product rule. I feel like product rule, y'all get that as well. Unless, again, sometimes we do strange things. I think it's when we get more variables in there. But if I'm going to multiply 2 terms with the same base, what do I do with the exponents? Add them. So this is x to the a plus b power. H squared times h to the 6th is not h to the 12th, right? We know that. It's going to be h to the what? 8, because I add 6 and 2. Yes? Okay. Now, don't confuse your exponent rules with your coefficient rules. Meaning when I look at number 2 here, I've got this negative 2 times 7. I handle that just like I have always handled that. What is negative 2 times 7? Negative 14. Okay? And then when I'm multiplying a squared times a cubed, that'll give me a to the what? 5th, right? Because I add the exponents. Y'all with me? And then b to the what? 2nd. Okay. Everybody okay with that? We good? Okay. Now, power to a power rule. This is where we get these two, the product and the power rule, kind of mixed up sometimes. We have x to the a power to the b power. This is when you multiply them. So this will be x to the a times b power. So x squared to the 3rd, this is when I actually multiply. That would give me x to the 6th. Okay. And if I have more than one thing inside of my parentheses, I can distribute it. Here's what we're not doing, okay? If I have x squared, no, if I have x plus 3 squared that does not equal x squared plus 3 squared. I do not get to distribute that because there's addition there, okay? Or subtraction, because earlier today I also had somebody goes, but if it was x minus 3, then you could, right? Absolutely not. Even if it is x minus 3 squared, that does not equal x squared minus 3 squared. Okay, that lands you in math jail. There's a mugshot over there and everything. But, and that's because I have addition or subtraction. Here, where they're multiplied together, it's totally fine. So I'm going to take negative 2 and square it. What's negative 2 squared? 4, positive 4, right? And then m to the 5th to the 2nd will give me m to the what? 10th. And then times m to the 3rd. So then that'll give me 4m to the what? 13th, right? I add them, I do not multiply them. Any questions about any of those rules? All sounds familiar, right? None of this is brand new. We're just reviewing and making sure we can handle all this stuff correctly. Okay. Then we have our quotient rule. Quotient means we're dividing. So when we multiplied them, we added the exponents. When you divide, you subtract the exponents. But you can also think of it as canceling out. We'll look at it both ways when we look at our examples here. So again, on number 1, I've got the x's with the exponents, but the 27 and the 42, those are just plain old numbers. I handle them just like plain old numbers. And so what are they both divisible by? 3. 27 divided by 3 is 9. 42 divided by 3 is 14. 14. And then maybe I can't reduce that anymore, but if I could do that the next step. I don't necessarily have to do it now if I didn't reduce it all the way, but I can't reduce it anymore. So then I have x to the 5th over x. So this is a 5, this is a 1. We know that even though we don't have it there. And 5 minus 1 is 4. So you can just think about it as subtracting, or you think about one of these cancels out with one of those and it leaves me with 4. Either way, but then that ends up on in the numerator and I get x to the 4th. Okay. What questions do we have? Anything? All right. On 2, before I start reducing anything, I want to go ahead and take my power to a power. So this will give me y to the 4th over y to the 4th. What does that give me? 1. They cancel out and I get 1. Everybody good? All right. Then our negative exponent rule. Here is, I think, the key to the whole negative exponent thing, is that if you don't already have a fraction, make a fraction. Put it over 1. All right? Then anything with the negative exponent goes to the other place. If it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. But that's only if everything's being multiplied. If there's addition and subtraction in there, I have to be careful. So x to the negative a over 1 would become 1 over x to the a power. And I promise you, if you make it into a fraction first, it will help you not do weird things, especially with the coefficients, because that's where y'all start to not be sure what to do with them. So when I look at this first example here, I'm going to put this over 1. Okay. Now, that negative 5 is negative, but it's not an exponent. It's just a number that's going to stay in the numerator, negative 5. The x has a negative exponent on it, so that x to the negative 2 gets moved to the denominator, and it becomes just plain old x squared down there. Everybody okay with that? And these are very simple, so you might be like, well, that's kind of dumb. I don't know how to do all that. But when you get more stuff in there, and we'll look at a couple of those examples in a minute, you'll see why that might be helpful. This is already a fraction, so I'm just going to leave it as a fraction. 4 over 8 reduces to what? 1/2, right? So 1/2. Then if you think about the actual quotient rule, that would be, it's k squared over k to the fifth. So 2 minus 5 is a negative 3, but then I put it in the denominator and have k cubed down here. Or you can look at it as 2 of these cancel out with 2 of these, and that leaves me with 3 down here. Either concept is fine. Questions? We all good on all that? All right. Then your zero exponent rule. X to the 0 power, what does that give you? 1. Okay. I'm going to show you why here in just a second. Some O's earlier. So be careful that this whole thing in number 1 doesn't become 1. This is 7 times x to the 0, so that's really 7 times 1, which is just 7. Would you have to write 7 times 1? No, but I just want you to see that you're not doing anything weird there. Okay. Now in number 2, we've got, this would be w to the 8th over w to the 8th, which is very much like this right here, right? And notice how we just canceled that out. If I actually subtract these, this is w to the 8 minus 8 power, which is w to the 0, which equals 1. Now, do you have to write all that out all the time? No, but that's why when you just cancel those out and they're identical, you also get 1. Okay, but that's why anything to the 0 power is going to give you 1. Okay, any questions at all? All right, then let me hand out your assignment. We're going to do some examples together. All right, let's start with number 12. Excuse me. Y'all find number 12. Want to make sure that you know what to do and you're not making up stuff when we have these exponents, okay? Everybody on 12? Girls, you on 12? All right. This whole parentheses has a negative 3 on it, so I'm going to make it into a fraction. Put it over 1. We're going to work from the outside in. Could I go ahead and distribute that negative 3? Yes, but I'm not going to. Instead, I'm going to take care of the whole thing because it's going to make my life easier. Since this whole thing is to a negative power, I'm going to make this into 1 over 6c times d to the negative 1 power to the 3rd. Okay, so notice when I did that, that negative 3 became a positive 3. It did not affect the negative 1 because it's inside there. Okay, you with me on that? You also don't want to try and move too much at once because that's when you also start to make up math. Now I'm going to distribute that 3. So this is going to give me, got 1 here, 6 to the 3rd power. I'm just going to go ahead and tell you that's 216. Then c to the 3rd power, and then d to the negative 3rd power. Everybody with me on that? So now, am I finished? No, because to be simplified all the way, I can't have any negative exponents. Everything's being multiplied here. So now anything with a negative exponent is going to change places. And so this d to the 3rd comes into the numerator, but the 216 c to the 3rd stays down there. It is not a negative 216 because it was a positive 6 to the 3rd. Okay. That's another reason why, like if I had distributed that negative 3 from the beginning, sometimes I'll do weird things with the negatives there, or then you're not sure what to do with the coefficients. So it's a little safer to kind of wait until the end. Okay, we good with all that? All right, then let's look at 14. Okay, so on 14, I've got, before I can actually combine these two things together, I need to go ahead. I don't have, these out here are not negative exponents. I don't care about what's going on the inside. So I'm not putting anything underneath right now. But I can distribute this squared. So this gives me 3 squared, which is 9, times x squared times y squared. Okay. Then I'm going to multiply that by, well, I've got negative 4 to the 3rd. What is negative 4 to the 3rd? Negative 64, yes. And it is a negative 64 because when you cube a negative number, it stays negative. So negative 64 times x to the what? 9th times y to the 6th. Okay. Everybody okay with where everything came from? Yes? All right, so 9 times negative 64, I'm just going to go ahead and tell you it's negative 576. And then this would be x to the what power? 11th, good. And y to the what? 8th. Any questions about where anything came from? All right, then I'm going to give you a minute. I want you to work on 15. Talk about it amongst yourselves, and then I'll... That doesn't help you on number 15. Nice try. Okay, do you agree with my first step? Oh, nope, because I missed that negative there. Now do you agree with my first step? I just distributed that 3, so I cubed 4, and then did my exponents correctly, hopefully. Since I have some negative exponents, I'm going to put this over 1. Then let's figure out what goes where. The 64, that stays in the numerator. A cubed, that's negative, so I bring it down here so that it can be positive. B to the 15th stays up here, and C to the 9th goes down here. Okay? Questions? Okay. Because something we got to be able to do. Now we're going to jump back up and do number 2 because I had a question on that earlier. I just want to make sure we... And the question was, well, it was more of a statement, really. No, actually, I guess it was a question because he said, what am I supposed to do to make this look like the other ones? Well, you can't. Like that's, I mean, you really can't. And we're combining like terms. Is the one I underlined like the other two? No. But these two I can combine. When I combine these two, what does that give me? 7xy and then minus 2x squared y, and I can't simplify it anymore. Could I factor out a GCF or like mess with it a little bit? Yeah, but I can't condense it anymore. And so I'm good where it is. Okay? We good on that? Do we understand why we can't put them together? Okay, because we're not multiplying, right? All right, now flip it over. I want to make sure you know how to handle this. We started start. Okay? See start? And then we've got to work this out. So negative 8 over 4, that'll reduce to a negative 2, right? And then x to the 18th over x to the 6th, what does that reduce to? X to the 12th. And then I really don't have anything in the denominator, so I didn't really even need one. But so then that tells me, so here's my answer, right? I had a bunch of things to choose from. So now I go here and now I work this question. And then that shows me where to go. And then I work the next one all the way to the finish line. Does that make sense? We good? All right. So you have the rest of the time to work on this. Yes, you do both sides. We did all the complicated ones on the other side, so it really won't take you that long, even though it looks like a lot of questions. Okay. Ask me questions, work with each other, make good use of your time.